lecture. So in this lecture, we would be covering the logistic regression. So as you know, the logistic regression is basically an unsupervised learning model, which basically allows you to predict certain labels, which could be yes and no. And let's take an example of what type of labels we can be predicting over here. So we can predict whether a person is a male or a female, whether the email is a spam or not spam, or a person is likely to say yes or no for a given decision, right? So predicting whether an input belongs to which class falls into two categories, which is basically yes and no, and we call it as a binary classification. So as for the binary classification, we can have a decision as a 0 pointing to no and 1 pointing to yes. So let's assume we have a hypothesis and we are trying to predict a gender, right? Based on their height and weight. So in that scenario, we are likely to take all the feature sets of that person, and using the logistic regression, we should be able to predict whether that gender has a probability of being a male or a female. All right, so a 0 would point, as I said, as a false category, and a 1 would falls to a true category. All right, so as far as the classification is concerned, predicting what class an input belongs to is extremely useful in many problems, such as determining whether someone can be approved for a loan. So let's say you go to a bank and you want to get your loan application to be approved. They're going to see certain features: what's your income, whether you're married, or whether you have graduated from the school. All those features should be considered as part of predicting the labels whether you're qualified for that loan or not, right? So logistic regression are not just limited to binary classifications also. In fact, they can be extended to multiple classes. Example, predicting the handwritten digits, right? Predicting the article categories, whether it's sports, politics, health, or also you can use them to predict the level of risk involved in investments, right? So now look at the expressions that goes behind the logistic regression. So if you remember from the previous lectures in the linear regression, we know that a function can be represented as, for all the feature sets that we're including, all the x variables, we associate certain weights to them and add a bias, which is a constant value over here, right? So that particular expression using a sigmoid function is represented as shown in the screen below, which is 1 divided by 1 plus e to e raised to the power of minus z. So this, and how do we really look at this expression in terms of the binary classification? So let's look at the next slide basically. So if you see in the right hand corner, I have a screen. If we have from our equation all the value sets and we plug those values in this expression of a sigmoid function, then those values would fall on the curve that's ranging from -6 in the lower left hand corner to the upper right corner that moves the values between 0 and 6. And assuming certain values fall um, at certain point in this graph, and if that value is less than zero point 0.5, we can treat the probability of that particular decision or a label that we are predicting is less than zero point 0.5, which means it should be treated as a zero value. And if the probability is greater than 50%, we will make sure that its likelihood to be is a different level, which is level 1. So that's how, using the sigmoid function, we can predict whether the particular label is going to fall into category 1 versus category 2. Also, logistic regression creates a decision boundaries. So in this picture, you can see that we have uh, a student being admitted to the school, and we are using the logistic regression to plot the decision boundaries over here. So these decision boundaries gives an idea of linear separation between the values. If you see the upper uh, dots that's beyond the boundary line, it basically shows the decision whether the students are admitted or not. So the upper part, if you see on the right hand corner, shows that the students are admitted. Those are um, you know, purple color dots, while the crosses shows that students who appeared in the exam are not having the highest score enough to be qualified, and that's why they fall into decision level of 0. That means they never qualified for that particular college based on the exams. So that's how we can use the logical regression to really predict the labels. And let's now take a deep dive into one of the example of building a logistic regression labels as part of exercise. Thank you, and thanks for joining this lecture.